All right, so welcome to the sixth beam problem that we have. So we have a simply supported beam, we have a pin and a roller here. So we have a pin and a roller, so we have a simply supported beam. So the first thing that we're going to do is we're going to find our reactions, then we're going to find our shear force and bending moment diagrams. And we have this distributed load of 12 kilonewtons per meter. So first thing, we can find our reactions. So let's call this point A and this point will be B. So our reaction, we're going to have a Y and we'll have a X for our pin. And for our roller, we just have a BY. We only have a BY. So from here, we can write our equilibrium equations. So sum of forces in the X direction equal to 0. So we're looking at any forces forwards or backwards. Backwards we call negative, forwards positive. We don't have any forces in these directions. We only have our AX reaction. So if we don't have any forces, our AX will be 0. So AX we can just write is equal to 0. So we have sum of forces in the Y direction equal to 0. So any forces up or down, down negative, and we'll go up positive. So we have 12 kilonewtons per meter acting down, and the distance is here, which is 2.5 meters. Our force is acting down, so we can write a negative 12 kilonewtons per meter multiplied by 2.5 meters. And then we have our AY and our BY, and both of them upwards direction. So those will be positive. So we can write plus AY plus BY, and this is equal to 0. And now we need to write our sum of moments around a point. So we can choose A or B. So let's choose A. We'll look at the moments around point A. So we can write here, sum of moments around point A will be equal to 0. So any moments acting in the anti-clockwise we'll call as positive, and any moments acting in the clockwise direction we'll call it negative. So we have our 12 kilonewtons per meter acting down. So how we can visualize this is, or how we can see this is, we have 12 kilonewtons per meter, and we need to convert this to kilonewtons, and then convert this to kilonewton meters. So we can get our moment. So these values are kilonewton meters, and these values are in kilonewtons. So these are forces, and these are moments. So just keep that in mind. These are forces, and these are moments. This is a moment. So we need to convert this. We need to get this into kilonewton meters. So how we do that is we can say this 12 kilonewtons per meter, convert it into a point load, which will act halfway of its distributed load. And that will be a force. That will be a force of kilonewtons. So how we do that is multiply by 2.5, which we've already done. So we can say this is negative 12 kilonewtons per meter multiplied by 2.5 meters, which is now a force, and we need to multiply this again by this distance. Our moment will be acting in this direction, and this distance we know is, this up to here is 1.5, and this will be half of 2.5 meters. So we know this will be half of 2.5 meters. So the total distance will be 1.5 plus 2.5 over 2, which will be equal to 2.75 meters. So here we can write 2.75 meters. And then we have our positive BY acting in this direction. So positive BY will be acting in the positive direction. It will be acting in the anti-clockwise direction. So we can write positive BY. The total length of our beam is 5 meters. So multiplied 5 meters. And this will be equal to 0. So if we solve for BY, our BY will be 16.5 kilonewtons. Then we can plug our BY into here. And we can find our AY. So if we do that, our AY will be equal to 13.5 kilonewtons. So we found our AY, we found our BY, and our AX was 0.